Hello teacher, we are going to talk about determination of the effect of red blood cell parameters in the discrimination of iron deficiency, anemia, and beta thalassemia by neighbor component analysis feature selection based machine learning. Introduction: Iron deficit anemia and beta thalassemia are two common forms of anemia with significant prevalence worldwide, especially in Mediterranean countries such as Turkey. Iron deficit anemia is caused by insufficient iron necessary from hemoglobin synthesis, which beta thalassemia is an eight blood disorder with more than 200 genetic mutation. The differential diagnostic between four conditions is traditionally based on tests such as hemoglobin A2 electrophoresis, serum iron levels, ferritin, and iron binding capacity. However, these tests are not always available in a center, which has led to the search for more accessible and economical methods such as the use of red blood cells indices. Job objective: The main objective of this study is to perform a differential diagnostic of iron deficiency, anemia, and beta thalassemia using accessible and measured red blood cells indices in any center and to evaluate the effectiveness of these indices using machine learning systems, introducing the neighbor components analysis filter selection algorithm to optimize diagnosis performance. Materials: The study was approved by the local ethics committee and included two groups of parents. 152 parents, 106 women, 46 men aged on the early age the diagnostic with beta thalassemia and Ellis Public Health Center between December 1st, 2016 and May 23, 2019. 119 patients, 116 women, 24 men from 2 to 8 years diagnostic with iron deficiency anemia in the biochemistry departments on Ellis City Hospital between March and the 5th on July 2018. All patients and a mean corpulous volume of and were not receiving iron therapy patients with hemoglobin A2 levels of 3.5 or more on high performance liquid chromatography were included in the beta thalassemia group. Hemoglobin A and hemoglobin F values were also recorded for each patient. Red blood cells parameters we measured with the Beckman control unicell analysis and hemoglobin A2 values we measured in chromatography with a Biora D10 analyzer.
Number 1. Method used for discriminating between IDA and beta thalassemia. Number 2. Initially, the measurements of RBC parameters were recorded for each patient. Number 3. Preprocessing was performed to convert these parameters into a processable format, and then index parameters were determined. Number 4. Subsequently, NC8 was performed to identify the effective parameters in the differentiation of ADA and beta thalassemia. Experimental results. Number 1. The effects of RBC indices used for IDA and beta thalassemia discrimination of machine learning performance. In addition, a subset of features were performed that showed the highest performance used NC8. Number 2. The RBC indices in the mixed male and female datasets include HCT, MCV, MCH, C, and RDW were more effective on the algorithm compared to other indices where body by NCHC and RDW show a win value more than 1. Number 3, the RBC index in the family dataset include HCT, MCV, NCHC, and RDW were more effective of the algorithm compared with other indices, where both the MCV, MCHC, and RDW. Number 4, according to the results, the highest accuracy MI and the lowest accuracy RI index were obtained.
The study focused on how different red blood cells indices affect the performance of machine learning algorithms to distinguish between two types of anemia: iron deficiency anemia, IDA, and beta thalassemia. They use a method called NCA to select the most important features that could help in this distinction. They found that certain RBC indices such as hematocrit, mean corpuscular volume, mean corpuscular hematocrit concentration, and red cell distribution width were more effective in the algorithms compared to others. The figure 6 shows the accuracy values of IDA and beta thalassemia discrimination obtained by using indexes in the literature. According to the results, the MI indexes was obtained with the highest accuracy and the RI index with the lowest accuracy. And the table 3 indicates that the performance of sorting across selective parameters using NCA was more successful than sorting across all parameters. The accuracy value in the male and female, their share increased from 95% to 95.3% with the selective parameters. Again, in females, the accuracy value was found to be 94.8% using parameters, while it increased to 95.5% across the selective parameters. For males, while the accuracy value was found to be 94.3% using all parameters. It will fall to be 94.5% through the selective parameters. Conclusion: discrimination between iron deficiency anemia, IDA, and beta thalassemia is crucial but challenging for diagnostic and treatment of anemia. This study investigated the use of different red blood cells parameters using a diffuse select algorithm, NCA, not previously used the literature. The result shows that the approach offers better discrimination ability that traditional indices reveal that different parameters are important for males and females.